Hi everyone, and welcome to Unit 43, more trigonometry. Today we're going to take a slight detour and we're going to look at Pythagoras' theorem in 3D. This is a really useful skill to enable us to calculate some missing sides in three-dimensional models. Sometimes we need to do this to enable us to then be able to do the trigonometry again. So let's have a look, see how this fits in. In terms of the big picture of what we're doing in this unit, we're now looking at being able to solve some problems in 3D, although specifically today I'm only going to look at Pythagoras and how that might help us. So specifically, we're going to look at calculating sort of diagonal lengths of cuboids using Pythagoras' theorem. You'll remember Pythagoras from when we've done it in class before. He came about with this idea about right-angled triangles. And one of the main things that we remember is that he discovered that for any right-angled triangle, the area of the square drawn on the hypotenuse, so that kind of longest side opposite the right angle, is equal to the sum of the square areas on the squares drawn on the other two sides. And more precisely, if we want to kind of visualize what's going on, you'll remember that we've got right-angled triangles like this. If we're finding the length of the hypotenuse, we square the two sides, we add them together, and it equals the square on the hypotenuse. So here we've got 9 and 16 adding to 25. We've got 25 over here, which means we can work out the length here by square rooting this value. Okay, so you'll have done lots of this. And remember various things, like when we're finding the longest side, you will remember that you can do c squared equals a squared plus b squared. Or if you get quite good at this, you might then just remember it as c is the square root of these two things added together squared. Okay, so again, when finding the longest side, you'll have got this knowledge already. You'll also remember when you're finding a shorter side, remember shorter side subtract. So if we're finding either a or b, you do c squared minus the other one squared. Okay, so whichever way around it is, you do the longest side first and then take away one of the shorter sides. Okay, so this is just a bit of a recap. Let's see how we can apply this then. So if we're going to now start to look at a three-dimensional model, we're now thinking, well, how am I going to get some triangles out of this? Let's have a look. The question wants us to calculate the length of A to F. So A to F is all the way up here. So from one corner all the way through the 3D shape to the other corner. And the way that I would always recommend starting doing this is breaking it up into smaller triangles so you can see what's going on. I will give you a really quick tip later on in the video to enable you to do this really quickly, but I want you to get the understanding first. So first of all, what I would suggest that you do is see if you can find the triangle that's formed like this. So we've got A to F, which is running up here. We've got F to C, which is down here. And then this bit is A to C. So it's along this diagonal, along the bottom of the 3D shape. Okay, so along this bottom face, along the diagonal there. Now, if we start to calculate this bit, then we'll have enough information to do Pythagoras on this little triangle. So we're starting out with our 3D image, breaking it up into two-dimensional right-angled triangles and calculating from there. So what we said was we needed to find this length. Well, this length, again, is a right-angled triangle. You need to kind of visualize what's happening here. You've got the base of this cuboid. This is a right angle, so ADC is a right angle. We've got 6 and we've got 8. Oh, there's a mistake there. That should be 8 along there. And we can calculate those to give us the length along AC, which is 10 centimeters. Now, going back to our previous image, what we said we wanted to know was how long AC was. Now, we've just calculated that AC is 10. So we can pop that in, and now we can use Pythagoras for a second time on this new triangle, ACF, and work out the longest side here, giving us 149 for AF squared, square root it, and we're going to get 12.2 centimeters. Okay, so we can do it by doing Pythagoras twice, one way, and it's quite a quick way to understand what's going on. It involves a little bit of spatial awareness, which I know some people find really difficult to do, but I would recommend trying to do it this way first. When you get good though, when you get good at it, we can literally just do a formula. Okay, so a bit like normal Pythagoras, we can now say that the diagonal squared is equal to a squared plus b squared plus c squared, which are just the three other sides that you've got. Okay, so you've got this dimension, which we can call a, this one we can call b, and this one we can call c. And similarly, if you just want to get d, you can square root everything in one go and get your answer. And this is really quite a quick way of doing it. It takes some practice and takes a little bit of understanding about what's going on. And so therefore I would always recommend doing it the more long-winded way first, but this is a quick fix for when you've got it. Similarly, we can also find the shorter length when you're given a diagonal. Okay, so just like we could find the shorter side, subtract, we're going to do the same thing here. We can say that any shorter side, let's say that this is a down here, we can say it's the diagonal squared minus c squared minus b squared. The only thing you need to be really careful of here is that these numbers, whatever the values are, go down in size. So let's say the diagonal was 12. The next value you would use is the longest side along the bottom. So in this case, maybe let's say it's 10, and then this one has to be 8. So these numbers have to go down in value for this to work. But again, it's a quick fix, something you can just type in your calculator quickly and get a solution. Okay, now what I'm going to suggest that we do at this point is have a practice of the skill. So there's a couple of questions on the worksheet attached on class charts. Give that a go, pause the video and see the answers. Here are the solutions to the two questions. Okay, so 34.4 and 7.84 centimetres. Hopefully you did those well. I'm going to set a few questions on Dr. Frost, but not too many. And say this is a skill that we'll use time and time again when we're looking at 3D problems. Okay, so hopefully you found this this video useful and fairly interesting, and say it's not a particularly difficult one. It's one that we're going to use as part of other things, but give it a go, have a go at those couple of questions, and if you're not sure about anything, let me know. Cheers, bye bye.